All right, guys, we have done some solving exponential equations and logarithmic equations in class, but I wanted to do a few examples of ones that were slightly more complicated before you jump into practice. So this problem has two exponential functions and they have different bases. I can't just drop the bases because they're different. I also cannot rewrite 5 to some power of 3, so that's not helpful. What I could do is take the log of both sides. There's different ways you could do it. You could take a common log, you could do the natural log. You can do the log of any base, but if we're being kind of smart about it, it probably makes sense to take the log of a base of one of the ones that this is that are here, like log base 5 or log base 3. I'm thinking I'm going to do log base 3 because that one has the more complicated exponent. So if I write it like this, I'm allowed to do that as long as I take log base 3 on this side as well. Okay. Now, we know based on our exponent rules that when you have an exponent, like a power on a logarithm, you can move it to the front. So I can rewrite this as x log base 3 of 5. And I can rewrite this as 2x minus 1 times log base 3 of 3. And then log base 3 of 3, I can actually evaluate pretty easily. That's 1, because 3 to the 1 is 3. And I cannot really evaluate log base 3 of 5 and get a whole number, so I'm going to leave it as it is. But knowing that this actually is a number, that is a number. Okay, obviously 1 times 2x minus 1 is still 2x minus 1. We almost have to go back to the solving skills that we used a little bit in our inverses unit recently. If I have x's on both sides, it would be a good idea to get the x's together. So this is going to be x log 3 base 5 minus 2x equals negative 1. So I got the x's on the same side. Now both of these terms do have an x in it, so I can factor that x out. And then I'm almost done. I'm trying to get the x alone, so I can divide that whole log base 3 of 5 minus 2. And that's it. You don't actually have to go any further than that. You're allowed to leave the log in your answer as long as there are numbers in there. Okay, next up we have a really weird one that is kind of a special case. It definitely is exponential, but you'll notice that we have two things with a base, something that doesn't have an exponent, and then we have two different exponents. But what I would like to point out is that this is a trinomial. It has 3 terms, and it's also set equal to 0. I would also like you to keep in mind, little note off to the side here, that e to the x squared is equal to e to the 2x. So even though it's not immediately obvious, this is actually a factorable equation. It kind of looks like a quadratic, like a trinomial that's a quadratic. It just happens to have x's in the exponents and e's as our base. But we're actually going to treat this just like we would treat any other kind of factoring question. How do we get e to the 2x? That would be e to the x times e to the x. Okay, because we just saw that over here. The e to the x times e to the x would be e to the 2x. I need two numbers that multiply to give me 2, but when they add together, give me negative 3. So two numbers that multiply to give me 2, but add together to give me negative 3. That would be negative 1 and negative 2. Before I actually solve this out, I just want to show how these are the same thing. So e to the x times e to the x is e to the 2x. E to the x times negative 2 is negative 2 e to the x. Negative 1 times e to the x is negative e to the x. And then negative 1 times negative 2 is plus 2. Notice that if I add these two together, that gives me negative 3 e to the x. And so that is why this in green is the factored form of what is in purple up there. Okay, so you can always double check yourself like that. So let me rewrite what we had in green. You don't have to do the blue part, but that is not, like, never a bad idea to just like check and make sure you factored correctly. Okay, when we have two factors and they are set equal to 0, the reason we set it equal to 0 is because anything times 0 is 0. So that means either e to the x minus 1 is 0 or e to the x minus 2 is 0. We like separate our factors, set them both equal to 0. This is what we have always done. You've been doing this since integrated 2. All right, so I'm going to do some algebra. I'm going to add 1 to both sides. Now, different ways to think about this. Some people think about taking the log to make it cancel out. Some people think about just like rewriting this in log form. Since I have an x stuck in my exponent, the way I get the x stuck out of get it out of the exponent is to rewrite this in log form. So if I rewrote this in log form, it would be log base e of 1 equals x. Remember though that log base e is the same thing as natural log. So the natural log of 1 equals x. That's one of my answers. Sorry, I said that, yeah. Is that what I meant? Yes, that's what I meant to say. Sorry. And if I think about this, e to the what power gives me 1. You might have been able to answer this without changing it to a log, but anything to the 0 power is 1. So x is 1. And again, you might have been able to just think about that here in the blue, but sometimes I think with the second one, we're definitely going to need to rewrite it. So looking at this second factor, if I add 2 to both sides, I have e to the x equals 2. I'm going to rewrite this as log base e of 2 equals x. Remember that log base e is the same thing as natural log. And so I just get the natural log of 2 equals x, and I also have 0 equals x. Just solved each of those. You do not have to know what the natural log of 2 is. You can just leave it as natural log of 2. Last one, and I'm realizing all of these were exponential functions that we had to use logarithms for. So we didn't actually use any logs in this particular, like we didn't start with logarithms. So I might throw one of those in. But for now, I can't rewrite anything as a log until I have the exponential part by itself. So I cannot solve for this x until I get rid of the 4 and the 2, first of all. So I do need to do order of operations backwards, which means I'm going to add first. Okay. Then I need to get rid of this 2, and I can divide by it because the 2 is being multiplied by everything in the parentheses. So this equals 3 to the 2x minus 5. I don't really need that parentheses. We can make it 7.5 if you want, or you can just leave it as 15 halves. Okay, now that I have the exponential part alone, I can take a log of both sides. The easiest way to get rid of stuff, you can always take any kind of log, like any base. But the easiest way to get rid of it is to take the log of the same base as the thing. So if I do log base 3 of this, okay, actually I'm going to back up for a second. You could take the log of both sides to make this go away. You also could just rewrite this in logarithmic form, and I'm going to show you how that's the same thing. So if I rewrote this in log form, the little part would be 3, this part would be 15 over 2, and this would be 2x minus 5. Do you see how that's actually the same thing as what's happening down here in the black? Because you would move this exponent to the front, and then log base 3 of 3 is actually 1. So it doesn't matter if you take the log of both sides or if you rewrite it into logarithmic form, you still end up with this either way. Okay. So here we are. We're trying to solve for x. Personally, I don't know what log base 3 of 15 over 2 is. So I'm going to leave that alone. Need to add 5. Please note, I'm not adding 5 to the 15 over 2 because the 15 over 2 is technically part of the logarithm. Like what's in parentheses here is a number. I just don't know what that number is off the top of my head. So I just kind of put a plus 5 on the outside. Then I'm going to divide everything by 2. Again, I would rather not actually evaluate this. I would prefer to leave it like this. And that is completely acceptable. This is a complete and good answer. In fact, when you guys get to calculus, you'll learn that it's honestly preferred for you not to simplify things. They kind of like stuff like this, so that way you don't make mistakes on the silly simplifying stuff. I'm going to throw in a bonus question. This is still a solving question because it's an equation with an equal sign and we're looking for x. But this time I have logarithms instead of having exponential functions. So the thing is, and I feel like the ultimate key with all of these is you're going to want to rewrite a logarithm into exponential or rewrite an exponential into a log. Since I'm starting with logarithms, it means I'm ultimately going to want to rewrite this as an exponential function. But I can't do that with this plus sign here. I have 2 logarithms. So we actually need to use our properties. And so I'm hoping you guys remember what to do with the plus sign. Remember that you can rewrite 2 logarithms being added if they have the same base as... Okay, sorry, the announcements interrupted me. Remember when you have a plus sign here and you have logarithms with the same base, you can rewrite it as the log of a product. So this times this as one single log. Okay, so I rewrote this one using log properties as a product of a single logarithm. Now, I think I'm going to go ahead and simplify this. So this is log base 3 of x squared plus 8x. Now I have a single logarithm, which means I can rewrite this into exponential form. 3 is going to be my base, 2 is my exponent, and then x squared plus 8x is going to be my answer. So base, exponent, answer. I have 9 equals x squared plus 8x. Now right away, I notice that we have quadratic going on here. And we have an x squared and we have an x. And so if I'm actually going to solve this, I need to set this equal to 0. Because that's how I solve quadratics. I have to factor them, and I can't factor them if they don't equal 0. So I set it equal to 0. Now I'm going to factor. Factored twice in this video. Can't forget factoring, it's important. X, X. I need, because there's a 1 in the front here, I just need 2 numbers that multiply to -9, but add to 8. That is going to be a positive 9 and a negative 1. So 9 times -1 gives me -9. 9 plus -1 gives me 8. And then I just solve these really simple equations where I set them both equal to 0. X equals -9, x equals 1. Now, the only thing we need to be careful with about this is sometimes when we simplify stuff with our properties, we end up with extraneous solutions, so ones that are extra and don't actually work. So if we look up at the top, the very original question up here in blue, see if you can actually plug in these things and it be okay. I cannot take the log of a negative number because it's not possible for me to do 3 to a power and get a negative number. So if I plugged a -9 in here, in either place, that would not be cool. It would not work. There's no 3 to a something power to give me -9. So that means that -9 is an extraneous solution. And if I go up to the top and plug in 1, I can actually test this out and see if it works. Log base 3 of 1 is going to be 0, because 3 to the 0 is going to be 1. And log base 3, if you plug a 1 in here, that'll be 9. Log base 3 of 9 is 2. So I have 0 plus 2. That gives me 2. Yay! So x does indeed equal 2.